Hello, calculus fans. I think I have a good video for you here today. I'm teaching Math 125 Calculus 2 this term, and a lot of students are, as is typical, are asking me, I don't remember graphs. I'm worried about graphing, and that it particularly pops up when we get to a section where we start doing areas and volumes and other things. And I just went through and I grabbed all the homework and all my recent exams, and I looked at everything I've asked students to graph in the last, like 5 or 6 years based off of exams and homework. I'm going to talk through those in just a second and show you can do them all, no problem, and hopefully that eases some of your worries. But I'll start with a quick general review. All right, and if this stuff is helpful, let me know in some way through comments or on the discussion board or on the YouTube channel, whatever is helpful. I'm trying to find things that are helpful for people, and by letting me know, I can make more. Anyways, so in general, it's good to know a lot about graphing. There's a lot to review, but I'm going to try to be quick here. You just really need to, for the most part, as I look through homework, lines, parabolas, sometimes powers and roots, sometimes exponentials and logarithms. It's good to know your trig functions, but these are the ones that come up the most. Circles, and I'm going to call hyperbolas, throw hyperbolas in there as that comes up every once in a while. These are those graphs. So a few comments, I'll give some equations here. You should know this is a parabola. It's a parabola with the x is squared and some sort of, and it's going to be positive in front of x squared because it's smiling. And maybe it's like -2 because it's shifted down. This one is x equals y squared plus maybe 3 or something, shifted over to the right. So the main thing to know if you've never seen the y squared version is it's the same as the x. If it's positive, it's smiling to the right. I guess it's not a smile, it's a C. If it's negative, it would be smiling the other way. All you really need to know is the basic shape, because at any point in the problems, you can plot a few points. If you know the basic shape and then plot 2 or 3 points, and the way you plot points is just pick some x values. You say, okay, if x is 1, then y is -1. And you plot 2 or 3, and knowing that and the general shape usually gives you more than enough to do what you need to do. You should know what the square root looks like, and pretty much any even root will look similar, just with different, how it's spaced out. You should know what the cube looks like. This is the cube root. I was just giving some examples. This looks like a parabola. It could be x to the 4th is what I was thinking. But basically we have odd powers, we have even powers, we have odd roots, we have even roots. That's what they look like. Those are powers and roots. Now when you start to mix things together, then you're going to need a bit of calculus, but that really doesn't happen very often, as I'll show you in these problems. Because when we're talking in Math 125, we're focusing on other things at the moment. Anyways, you definitely should know what e to the x looks like, and you should know what log looks like. Now you should also know their inverses, and when you have inverses like these two, or these two, they're symmetric over the line y equals x. So if you can remember one graph, you can remember the other. You should know that that sine starts at 0. So again, I'm just trying to quickly get through this. You should know that cosine starts at 1. It's good to know in general what tangent looks like. It has a whole bunch of asymptotes because it's sine over cosine. So whenever cosine is 0, you have these asymptotes, which is pi over 2 and negative pi over 2 and many others. Arctangent just does a reflection of the first branch of tangent. So here's arctangent. And it looks like this. And it's good to remember this is pi over 2 and negative pi over 2. Often those come up in limits. And then finally circles. So let's take a circle. I don't know. I'll make it radius 4. And usually we want to make it a function. So sometimes we want the upper semicircle, which would be the square root of 4 minus x squared. And that gives those points. Sometimes we want the lower semicircle, which is negative the square. If you don't know where I'm getting that, I'm just solving for y. Here is the x's that are negative, so it's negative the square root of 4 minus y squared. Here's the x's that are positive. Those come up quite a bit, so it's good to know that shape and recognize it. And then finally this hyperbola that looks like this. If it's an x squared, it looks pretty similar. It's just positive on both sides. So given a problem, it's usually what you should do, even maybe before you graph, is find the intersections if you have more than one graph. Maybe if it's easy to do, find the intercepts, meaning plug in x equals 0. It always doesn't hurt to plot a couple points to make sure it's reasonable, meaning you could just make a table, plot in 0, -1, and 1, see what you get for y, and then make sure your graph hits those. And then the calculus part is taking the derivative and set it equal to 0, which is really good at finding peaks and valleys. Okay, so let's go look at your homework. So we're going to shift over. Here's the 6-1 homework. I'm not going to do the problems. Right now I'm just focusing on how are you going to generate that graph. And when you're doing the homework, please don't use Desmos or other resources because you have to practice like it's a test, and you don't have those during a test. So you should, when you see this, you should think parabola, line. And they actually give you a picture in there, but it's a parabola, but it has this middle term. This is where a bit of calculus helps. Some people remember the vertex formula. I know it's a parabola, so I kind of want to take the derivative and set it equal to 0 and get x is -5 over -2 or 2.5. That's where the vertex is. So in my head, I'm already starting to think it's a sad parabola. There's 2.5. Let's plug in some numbers. When I plug in 0, I get 0. So you can see how I generate these pictures. It's not because I just know what they all, I just have a process for thinking about them. And then I have this line, y equals 2x, so it goes to the origin. So I didn't even write it, but I plugged in 0 to both as I was doing it. I was like, oh, they both go through the origin. And if I had to do more stuff with this problem, the next thing I would do is find their intersection, get everything to one side, factor. Yes, that takes some practice, but that's it. Now, you really would not do much more than that in these problems. Don't spend a whole bunch more time trying to label everything. Don't spend a bunch of time trying to be super accurate in your picture. You just really need to know which one's on top and which one's on bottom. So if you've switched your focus, this isn't so bad. Okay, what do we got here? So when I see these, I think hyperbolas. And so in my mind, I'm thinking of that graph I mentioned a moment ago, something like this, or the square might be something like this. But the biggest thing is figuring out which one's on top and which one's on bottom. So again, I'd plug in points. I wouldn't plug in 0 because that gives me an error. I'd plug in 1, and I would get, let's sort of do each of these. This gives me 2, and this gives me 2. So there gives me a start. I have a general picture in my head, and I have a starting place. And the starting place, I have a point. That when we're at 1, it should be about 2 right there. And then it's going to, now I know it's going to swoop down. Wouldn't hurt to plug in 7 because the question mentioned 7. So this is going to be 2 over 7. And this is going to be 2 over 49. 2 over 49 is smaller. And so it's below. So I'm going to go out here to 7, wherever that is. I'm not trying to be accurate. One of them is going to be 2 over 49. And one of them is going to be 2 over 7. And now that I draw it, you can see why I'm not trying not to be precise. It's not going to look very accurate. That's all right. So I'm going to go 1, 2, at this point up here. One of the graphs is going to come down here. And this, I know this because I know the general shape of these hyperbolas. So you can see how I got that fairly quickly. You do need to know that that's all the points when x is 7. So that's a vertical line. If you can't remember that, just plot a bunch of points. It should be all the points that have a 7, and a 7, and a 7 in the first spot. Don't try to guess. There's my region. So it was tougher, but just knowing the general shape and plotting 2 points got me the graph. Okay, what about this homework question? What am I thinking? Parabola, line. Yeah, it looks a little different than I'm used to, so let's solve for x. It's equal to 8 minus y squared. X is equal, and again, don't try to avoid using Desmos or something else here. It's a sad parabola, but from the y's perspective. And you've got the line y equals x. So let's play this game. I have a sad parabola. And when x, and now I'd plug in values for y. When y is 0, you get x is 4 for one of them and 0 for the other one. So I've got this 4, I've got this 0. I know it's a sad parabola from the y's perspective. Okay. That might be new to you, but it's not much to pick up. And then I have the line y equals x. I kind of missed there. There we go. So that's the game. We have two happy parabolas from the y's perspective. Let's play that game. And you would find the intersection. You're going to have to do the problem. I'm just showing you how I think about how quickly we can get the general shape without having to use a graphing calculator. So we have a happy parabola. I actually plugged in a number. When this was 0, this was 0. So that's how I got that. When this is 0, this is 8. So I have another happy parabola. Now, the question says between those two things. So the question itself gives me a little hint about graphing, which is these things must run into each other in some way. So we must be dealing with something like this. Again, that's not very precise. It's kind of terrible what I drew. But now I have a general idea and I could plot a few more points. Here's probably the hardest one in the homework because you go, well, I don't know what those are. Those aren't in our list. But it's the same idea. We know what sine looks like. We know that it starts at 0. Is how I would think about it. So sine starts at 0. And you might say, well, it's squared. But that doesn't matter. It's still 0. And when I plug in 0, I get 1 for the other one. So let's put a little dot for that. So now I have 2 dots. I plugged in 0 to both of them. This is 1. And the other one is 0. The other point I'd plug in is 1 because the problem mentions it. So if I plug in a 1, sine of pi over 4 is root 2 over 2. And then we're squaring, which is funny because it's 2 over 4 or half. Okay, so I go over here to 1, and I put a little dot at a half. And I do, in this case, have to know a little bit about how sine behaves, that it starts at 0 and goes up, and how cosine behaves, that it starts at 1 and goes down. But now I think I have an idea of what's going on. It's there. It's there. And at least as a starting place, maybe there was more going on, but I have a start. And if the question just asked me to think about the area, now I know which one's on top. It's the cosine one because start. Okay, so there's the game. Now when you get to section 6.2, you're going to have some questions like this. And this is what I was thinking about when I thought I better mention the half circles. Because in order to do this problem, and more on this in the days to come, you're going to need to be working with this half circle. And then we're going to rotate it around. Or you might want to work with this half circle and take a little piece over here and rotate it around. We'll talk about that. So how are you going to get those equations? Well, the equation for the circle in general in 2D is this. If you want a point here and you want to describe how long that is, you're going to solve for x. So x is going to be the square root of r squared minus y squared. So I've just taken that and I've rearranged to get x by itself. If you want to know what this height is, you're going to solve for y. Y is the square root of r squared minus x squared. So half circles come up a lot in applied problems. Okay, so what would this look like on an exam? What have I asked people to graph on an exam? So you say, I'm worried about that. That's going to take me forever. Let's take a look. So I went through and I grabbed every graphing question, every question I've asked in recent years where a graph was involved. So each one of these you can try to graph on your own. So I had a question that said, find the area of this region. On that one, I think I did not provide a graph. And so in order to do it, you would have to provide the graph for yourself. So what do we got? A line and a root. So you would go here. If it helps to write this way, you can. And if it helps to write this way, you can. There's a little difference between these, which is this one's only positive. But you can think of it both ways now. So in my mind, I would have drawn this, because I know in general what the square root looks like. And I would have drawn a line that has slope 1/3. Boom. To me, that's not too bad. I don't think it should be too bad for you. At some point, you're going to need to know this intersection point and this intersection point to do the problem. And the way you do that is combine. In my opinion, maybe the easiest way would be to substitute this in here. But you could also substitute that. Anyways, I'm going to do y squared equals 3y. We've talked about this a few times in class, how the best way to do this is get everything to one side and factor. And you get two answers, y equals 0. So one of them has y coordinate 0. The other has y coordinate 3. And once you know the y coordinate, you know the x coordinate. X has to be 9. X has to be 0. And now we're off and running. You need to practice that in the homework. So to me, as someone who's done these on their own without looking at Desmos, this will be no problem. Okay, let's look at another one. In any one of these, you could pause and try to do a quick sketch yourself. Consider the region bounded by e to the x, y equals 0, x equals 1. Okay, so let's draw this. It mentions x equals 2, so there we go, a vertical line. And it's the e to the x graph. We should generally know what e to the x looks like. So there's a start. We should draw a vertical line at 0. We should draw a vertical line at 2. And it mentions y equals 0, which is this side. Done. Now the question asks you to do more with it, but right now I'm focusing on the graph. So that would have been the first thing I would have done. Next one, let's keep going. Pause it. And you can try it yourself. This is just an old exam. Let R be this region bounded by those. Uh-oh, it's a fourth root. That's kind of scary looking. But not really. It's going to look just like a square root. Now this time there's a y equals 3. Again, at any point if you forget whether it's a horizontal or vertical line, think about what happens if you have a bunch of points where the y is 3. If it helps draw a few. What do those all have in common? It's a horizontal line. So anyways, there would be probably the first thing I would draw would be this root. I would just draw it so it looks like a square root. Fourth root is just a little bit steeper, or I guess less steep, I should say. And then I want to draw a line here. Y equals 3, and it mentions x equals 0. This is a really valuable skill just to be able to visualize. If you always have to go to a graphing calculator for every type of function, that's going to take you a lot longer to think through problems. At some point you're going to find the intersection. That's actually not so bad, because the intersection would be when this is true, which is 1 is the fourth root of x. So x is 1 to the fourth, or just 1. So I know that's at 1. So this is 1, 3, and we're ready to go. The question then asks you to do some stuff with that. Okay, so if you're starting to get this, let's do a few more. This is just good practice. So here's for my fall 2011 exam, or 2017 exam. And I ask you to draw a cubic, x equals 1, in the x-axis. X equals 2. X equals 2. Here's 2. And then we're going to draw a cubic. Swoops over, it comes over, it hits this, and the x-axis. It's a question asking me to find the intersection. The intersection is going to be at 2, 8, so that was faster. Done. So I hope you're gaining a little comfort here. I'm never really trying to give you a hard graph on the test, because that's not the goal. But I also don't feel like I should have to graph everything. You do have some expectation in this course that you know these functions. Compute the area of this region. So they give it to you in a funny way, but it's a parabola. Let's write it in a more standard way. It's a sad parabola, but from the y's perspective. Okay, so we have a sad parabola. Let's plot some points. When you plug in 0, you get 0 for y, you get 2. So it's going to be 0, 2. And if you plug in 1, it's sad. It goes this way. There we go. And then we're going to draw this line. Y equals x. Yay, we got it. You're going to find that area. Consider this region. A few more. Hope this is sort of helping. Another exam question. These are every single place I could find in my exams where you had to graph. We have a line. We have a basic parabola. Okay, so we have a basic parabola. We have the line 6x. There's the region. This is 6, I suspect. This is 36. Yep, because when you plug it in, you get 36. Done. So I hope this is putting you a little more at ease. Of course, you should do some more old exams yourself. Anyways, let this be. So we have a horizontal line. This time I said horizontal because too many students were making mistakes. We have the cubic graph. So we have the cubic graph. We have the horizontal line, y equals 8. And we have the y-axis. You don't have to make sound effects. That's fun. And then we'll get this area. Might be nice to know where that point is. I know the y-coordinate is 8. Just need to know what the x-coordinate is. So it's got to be 2. Done. I think everybody can do this. What about this one? Looks scary. So I think there's a certain thing on exams when something looks a little different, people kind of freak out. Know that I'm not trying to trick you. I think I did it this way to avoid a confusion, but sometimes in doing so, it confuses people more. But y equals the square root of x, that's this. Y equals the negative square root of x is the same thing, but down here. And then I have this line. I know it's kind of written in a funny way, so if you wanted to, you could rearrange it. 3y is x minus 10. Y is a third, x minus 10 thirds. So the intercept is somewhere down here, and it has a positive slope. Okay, so something like this. There we go. This would be much easier to do with y, and so I would much rather write x equals y squared. But that's not what this video is about. It's just video is about drawing. Okay, we have this one, hyperbola. So the very first thing I would draw is this and this. It mentions 1 and 9. So I plug in a 1, this is 1. I plug in a 9, this is 1 over 81. Done. Okay, this one mentions a parabola and a line. Again, if you don't know your vertex formula, that's fine. You'll just need to remember a little calculus. Take the derivative, set it equal to 0. That tells you where the bump is, which we call the vertex. Okay, so we have a parabola that has a vertex at 3. It's a sad parabola. When you plug in 0, you get 0. So it's this. So you can see on exams, I try not to push you too hard on graphs. I just do need you to be able to graph a little bit. I hope that helps. Let me know if videos like this are helpful. I do think that's one that should solve a lot of problems for some of you. I think I'll make a separate video about labeling graphs, which is the other skill that comes up specific to this course. Hope that helps.